Hold up. Wait a minute. Something ain't right.
Let's take a very quick look at a way to represent really, really big numbers. This is called tetration, and we'll see when we do this why you probably did not learn this at school. We'll start off by taking a quick look at the hierarchy of arithmetic operations. So level 0, the beginning level, would be succession. Now that is just moving up by 1 each time. So if we start with A, we're just going to have A plus 1. That's level 0, but let's go up to the next level. Level 1 is addition. Now addition, we generally write things like A plus B. But what does this actually mean? Well, it actually means A, we're going to add 1, and then we're going to do it again, and we're going to do it again, and we're going to do it again, and yada yada yada, you get the idea. We're going to add 1, but how many times are we going to do this? We're going to do it B times. So this is what addition is. It is just succession, but you do it a B number of times. So really what we're talking about is repeated succession, and that's what addition is. It's repeated succession. Let's jump up a level. We'll go to level 2, and that is multiplication. So multiplication, we can write A times B. But what does A times B actually mean? Well, it means we're going to start with A, and we're going to have another one, and another one, and another one, and etc. Now this is really repeated addition. We're simply adding A. How many times do we add A? Well, we add A B number of times. So it's just addition, but B number of times. The next level up is exponentiation, level 3. And what we do here is we say A raised to the power of B. So A is the base and B is the indice or the exponent. But what does this actually mean? Well, it means that A has been multiplied by itself. A times A times A times A, etc. And this is, of course, just repeated multiplication. How many times do we repeat it? Well, we repeat it B times. Just like in the previous examples, we do it B times, B number of times. So that's all exponentiation is, repeated multiplication. And that brings us to level 4. And this is the one that we're actually wanting to talk about. Level 4, tetration. Of course, tet meaning 4. Think tetra, 4. So tetration kind of looks like exponentiation. We have A and we have a B up in the air, but this time actually the B is on the other side. So it kind of looks like someone wrote A to the power of B, but they wrote it incorrectly. They wrote it wrong. But no, this is how we write tetration. And what this means is, well, actually, if we follow the previous examples, addition was repeated succession, multiplication, repeated addition, exponentiation was repeated multiplication. So what do you think this one might be? Tetration is, of course, repeated exponentiation. So what we have, this we say A tetrated to B. What we have is A raised to the power of A, which is also raised to the power of A, which is also raised to the power of A, which is also, and you get the idea. Now, how many times do we do this? Well, just like the others, we do this B number of times. Now, this is sometimes called a power tower because we're talking to the power of, to the power of, to the power of, to the power of. So it can be referred to as a power tower. Let's have a look at some examples of tetration, and we'll see that the numbers can get really big really fast. Let's start with some rather small digits. We'll have a 2 and a 3. So we say 2 tetrated to 3, or 2 to the third tetration. What this actually means, let's write it out. We have 2 is raised to the power of 2, which is also raised to the power of 2. Now we actually have to work backwards from this. So we work down this way. So the 2 squared up in the air, that's going to be 4. 2 squared is 4. So we have now 2 is raised to the power of 4. So we have 2 times 2 times 2 times 2, and that is 16. So far so good. That wasn't too bad, was it? Let's titrate 2 to the 4th tetration. So we'll stay with our 2, but we'll raise it to the 4th tetration. What we have, this is another way to write 2 to the power of 2 to the power of 2 to the power of 2. Now remember, we work from the top down. We're working backwards down through these. So this 2 squared up in the air, that will give us a 4. So what we're really saying is 2 to the power of 2. Hey, come back. There you go. To the power of 4. And now we do the next part. Well, 2 to the 4, 2 to the 4th power, we just did this one. That's going to give us 16. So now we have 2 to the power of 16. And we could go 2 times 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 2. We need 16 of them. We could do that one, or we could just reach for our calculator. And when we punch in 2 to the power of 16 on the calculator, we get an answer of 65,536. So 2 to the 4th tetration is equal to 65,536. Now 2 to the 3rd tetration was only equal to 16. So you can see we're jumping up quite a lot, quite fast, quite quickly. Now, I mentioned that we could do this on the calculator. We can do that because right here, this is the button for the number that you wanted to the power of x to the power of something. So if we put in 2 and then hit this button, it will ask us, well, what do you want to go to the power of? So we could put in 16 and then hit the equals. However, if you keep hitting that button to the power of, to the power of, to the power of, well, that's like our power tower, isn't it? So you could keep hitting that button and get another square, another square, another square, etc. And then you could populate that with a 2 and a 2 and a 2. So your calculator can actually do tetration. It has that ability so long as you keep the numbers really small. Like if we do this one, 2 tetrated to the 4th, or 2 to the 4th tetration, we get the answer of 65,536. So yes, our calculator can do that. But as we'll see, only if we keep the numbers small. Let's have a look at a different example. Instead of a 2 this time, we'll use a 3. Let's titrate 3 to the 3rd, so 3 to the 3rd tetration. If we write out what this actually means, it's 3 cubed cubed. Well, 3 cubed is going to give us 27, because 3 3s are 9 and 3 9s are 27. So now we're coming down to 3 to the power of 27. And as you can imagine, hopefully you can imagine, this is going to get rather a large number. It is, in fact, equal to, what have we got? 7, 6, 2, 5, 5, 9, 7, 4, 8, 4, 9, 8, 7. And no, there are no decimal places here. 3 to the 3rd tetration is equal to 7,625,597,484,987. That is a massively large number. And all we've done is 3 to the 3rd tetration. Imagine if we did 3 to the 4th tetration. What would that be? Well, we can do that in theory, because all we're going to do is add another 3. So what we would have, 3 to the 4th tetration would be 3 to the power of 7,625,597,484,987. The issue with that is, well, when I did it on my phone's calculator, it says calculation outside accepted range. So I reached for my actual calculator, my FX82, and it got an answer of maths error. It thought there was something wrong. Well, there isn't anything wrong. You can, of course, have 3 raised to the power of 7.5 trillion, but my calculator doesn't have enough power for that. Neither does the calculator on my phone. So whilst it could be done if you had this supercomputer, my calculator is not going to do it. And that's probably why you have never covered tetration in school, simply because the numbers just get so big so quickly. Your calculator can't deal with it, can't handle it. Now there is a rather large tetration, and we'll do one more example that we can do because we don't need a calculator. And we can do this one because we're talking about 10. Let's take the third tetration of 10. Well, we can do this because hopefully we know how to work with 10 in terms of normal exponentiation. When we have 10 squared, let's write this down, 10 squared, the 2's over on the right now, well, this is 100. And if we had 10 to the power of 3, 10 cubed, we have 1,000. If we had 10 to the 4th power, we have 10,000. And hopefully see the pattern here. Whatever we're raising 10 to the power of, that's the number of zeros. 10 to the power of 2, we have 2 zeros. 10 to the 3rd power, we have 3 zeros. 10 to the 4th power, we have 4 zeros. So we can use that knowledge to work out the third tetration of 10. Because, of course, what 10 to the third tetration actually means is 10 to the power of 10 to the power of 10. Well, remember when we had 10 squared, 2 zeros, 10 cubed, 3 zeros, 10 to the 4th power, 4 zeros. So 10 to the 10 will be 10 zeros. So what we have is, remember working backwards from the top, so this 10 to the power of 10 is going to be a 1 with 10 zeros, which makes it, of course, 10 billion. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 1 with 10 zeros. So that's the first part, our first step. We now have 10 to the power of 10 billion. So, okay, can we do this without a calculator? Well, yeah, we can, by applying the same reasoning. 10 to the power of 10 billion, well, how many zeros will that have? That will have 10 billion zeros. So we have a 1 at the start, but this 1 is followed by 10 billion zeros. And that is a really massively large number. I'm not sure if people generally can grab just how big that is at first glance. A 1 followed by 10 billion zeros. Well, let's ask ourselves, how many atoms are there in the observable universe, the entire universe? Well, that's been estimated. And the estimation for the number of atoms in the universe is somewhere between 10 to the 78 and 10 to the 82. That's the number of atoms in the universe, a mere 10 to the 82. Well, we've got 10 to the 10 billion. So this is incredibly huge. We could do this one without a calculator simply because the base was 10, and so we can just add on a certain number of zeros. That makes that part easy. But yeah, incredibly large numbers with tetration, which is why you've probably never come across it. The thing is, it doesn't end there. Remember, tetra 4, tetration is the 4th level of hierarchy in arithmetic operations. But there's also level 5 pentation, level 6 hexation, and to these I just say no. I'm not going there. Tetration was fun though.
If you like this video, punch that like button. If you want to see more videos, smash that subscribe.